Hey everybody, my name is Chris and I'm a tutor here at Chegg.com, and I mostly do math and a little bit of computer science. And in this video we're going to do an example with the factor theorem. So here we want to use the factor theorem to show that x minus 1 is a factor of f of x equals x to the 7th minus x to the 5th plus 2x to the 4th minus 3x squared minus x plus 2. So before we jump into this, let's go ahead and see what the factor theorem actually says. And it says the number c is a root of the polynomial f of x if and only if x minus c is a factor of f of x. Okay, so now I don't want to prove this theorem, but let's go ahead and investigate why it might be true. So what does it mean for the number c to be a root of the polynomial f of x? Well, if c is a root, so x equals c is a root of f of x. So what that means is that's the same exact thing as saying that f of c equals 0. So in other words, if we plug c in for x, then the result that we get is going to be 0. So that's identical to saying that x equals c is a root of f of x. Okay, so now how does that relate to the factor theorem here? Well, so f of x is a polynomial. Okay, so f of x is a polynomial, so we can say f of x equals, say, ax to the n plus, or sorry, a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus dot 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 plus a sub 1x plus a 0. Now, what does it mean if x minus c is a factor? Well, if x minus c is a factor, then that means that we can pull out a factor of x minus c, okay? And then we're going to see that, what about the rest of this? Well, if we pull a factor like this out from an nth degree polynomial, then everything that's going to be left is going to have degree n minus 1. So I'll say this here, plus b sub n minus 2, x sub n minus 2, plus dot dot dot, plus b sub 1x, plus b sub 0. Now, why did I change my a's to b's? Well, because when we pull out this factor of x minus c, all these coefficients are probably going to change in the factorization. I mean, the a's, of course, will still be the same, but they're going to be very likely different from the coefficients that are here in this extra factor over here. Okay, so, and again, because the original f of x has degree n, it's just how we wrote it down, then once we pull out this factor of x minus c, which has degree 1, because that's x to the first minus c, then what's really happening there is what's left over is going to have degree n minus 1. Because if you take a degree 1 polynomial and multiply it by degree n minus 1, then the product is going to have 1 plus n minus 1 equals n as its degree. Okay? So that's all that's going on there. So now here, let's go back to this. So the number c is a root of the polynomial f of x if and only if x minus c is a factor of f of x. Well, here, if x minus c is a factor, then what happens? So again, this is f of x. Now what happens if we let x be c? Then we get f of c equals c minus c times a bunch of stuff in here. Who cares what's in here? Because c minus c is 0. So we have 0 multiplied by a bunch of stuff, which is just 0. Okay? So this is just sort of just a brief outline of what's going on with the factor theorem, and really I only talked about one direction. So this is really two directions here, right? If and only if. So what that really means is there's two directions that actually have to be shown, and this really only explains one of them. And even then it's just kind of a general outline. So that's just kind of what's going on there, though, is if f of x can be factored like this, then if you let x be c, then you're going to get 0 right here. Okay, so that's just a little sort of high-level explanation of what's happening there. Now let's go ahead and see how to use this. So remember, x minus c is a factor if f of c equals 0. So in our case, for us, c equals 1. So let's see. So let's see if f of 1 equals 0. Okay, so in our case, we're going to have f of 1 equals 1 to the 7th minus 1 to the 5th plus 2 times 1 to the 4th minus 3 times 1 squared minus 1 plus 2. All right, so all I did was I just took 1 and stuck it in here for x. So 1 to the 7th minus 1 to the 5th plus 2 times 1 to the 4th minus 3 times 1 squared minus 1 plus 2. Now we just simplify. 1 to the 7th is 1, 1 to the 5th is 1, 1 to the 4th is 1, so plus 2, and then this is just minus 3, minus 1, plus 2. Okay, now 1 minus 1 is 0, so this all goes away. And then 2 minus 3 is negative 1. So we have negative 1 minus 1 plus 2. Well, negative 1 minus 1 is negative 2, and then we have negative 2 plus 2, which is just 0. So we just verified that f of 1 is 0. Therefore, by the factor theorem, x minus 1, so f of 1 equals 0, so by the factor theorem, x minus 1 is a factor of f of x. Okay, so that's pretty much all that we have to do there, is just verify that f of 1 equals 0 to show that x minus 1 is a factor of f of x. So this has been an example of using the factor theorem to show that something is a factor of this polynomial here. And we also talked a little bit about why this might actually be true. So I hope you found this video helpful, and thank you for watching.